Kaner, right? You might be wondering, oh my gosh, Professor Kaner looks amazing. Can we know a little bit more about him? Well, Professor Kaner received his PhD in inorganic chemistry from University of Pennsylvania in 1984. After carrying out some postdoc research at University of Berkeley, he joined the University of California, Los Angeles. In 1987, became a full professor in 1993. Professor Kaner is recognized for his work on refractory materials, including new synthetic routes to ceramics, intercalation compounds, superhard materials, graphene, and conducting polymers. Okay, so during his talk, Fun with Plastics, Professor Kaner will seek to explore fun questions such as, where do plastics come from, right? Do you ever wonder about that? And which plastic can be recycled? Can packing peanuts be recycled? That's a fun question, right? How long are polymer chains? And how many polymer chains are in a bowling ball? As well as, how are you supposed to open up a ketchup package if there's no perforation marks? Okay, so many great questions. And Professor Kaner is going to explain to us about those. As well, if you guys have any questions during the talk, feel free to leave it in the comments and we will go over them at the end. Okay, thank you guys, and thank you, Professor Kaner. Please feel free to take it away.
All right, I hope everybody's having fun at Explore Your Universe. I'd like to do this, and I hope that next year you guys can come back and we can do some of these experiments in person. But today I want to talk about plastics and polymers and where do they come from and what are they and what can we do with them. And you see some very colorful ones here, some rubber bands and a plastic Ziploc bag and some balloons. And if you think about it, if you think about rubber bands, what is it? It's rubber. And where does rubber come from? Well, rubber comes from a tree. And I'm going to start with a little experiment here. And this is with a Ziploc bag. It's something you can do at home. It's something I like to do in person. Just be sure you talk to your parents before you do it. It's called the magic bag trick. And what we're going to do is we're going to take a Ziploc and some sharpened pencils, and we're going to fill the Ziploc with water, seal it up, and stick the pencil in. What do you think is going to happen when we stick the pencil in? Well, you might think that it will leak. But plastics are really cool because they're stretchable. And so here's the water going into the Ziploc bag. So as I said, you can do this at home. Just make sure you've got a little container under you. And I like to do this with a gallon Ziploc because it's more fun. You can take a pencil and you can put it in. There you go. And you can push it all the way through. And look at that, nothing happens, it doesn't leak. And this is because the polymer strands simply reform and they mold themselves around the pencil. And you can do this with as many pencils as you want or other objects. Of course, you can't pull it out because if you do, it will start to leak. But it's a fun experiment to do, and you can do it at home. All right, so where do these polymers come from? Well, originally they came from the sap of trees. So there's a tree known as the gutta percha tree, or in Brazil, the Hevea brasilia tree. And if we were together, I actually had a conference in Brazil, and I visited a lab that worked on rubber, and they gave me some of the sap from the tree, and it's white. Now, when you think of rubber, like rubber tires, of course, it's not white. So what do? They used to have white tires, but they realized they got dirty by the time you got home. People didn't like that. So they had carbon black to make them black. And some people still like white tires. So they have a white stripe. They call them white wall tires. But the trick is, how do you go from this white sap, and the Native Americans used to use it to play ball with, but it had a problem, and that is, if you leave it sit, the ball will kind of sag. And so it took a guy named Goodyear, you've heard of Goodyear tires, and he was playing around with this sap and some sulfur on, and he accidentally heated it up, and it caused it to form a solid. And we had Goodyear tires, and he called it vulcanization. And it's really just the sulfur causing a chemical reaction. And here it is. So there's Charles Goodyear, and here's his supposed kitchen that he's playing with. And here's the sulfur, and it makes these what are called crosslinks. And from that, he turned this polymer, this sap that would run all over, into tires. And we use this process today, and he called it vulcanization after the god Vulcan. And here's a bunch of rubber things. You may know an eraser. If you go to England, they're called rubbers. Why? Because they're used to rub off pencil lead. And again, some more rubber bands. And if you take a rubber band and you pull on it, there's an experiment I like to do where you pull on it and you put in some energy. And when you release it, you release that energy and you can feel the rubber band getting hot and cold. Now, rubber has a property called creep, and that is a time-dependent change. And we know this because if you take a deck of cards and you put a rubber band on, and you come back a couple of years later, you'll find that that rubber band often snaps or is broken. And the reason is if you put tension on a polymer, polymer are these long strands, they're millions of units long. And so you can think of springs that are coiled up millions of units long. And if you keep pulling on it, eventually they pull past each other and the springs don't know how to get back to where they were. So rubber band works many times, but it doesn't work forever. And if you leave it in the stretch position, it will eventually break. And it's a process called creep. All right, here's a fun experiment that I also like to do. This is sticking a balloon into liquid nitrogen. So let's take a look at this one.
Frostbite Theater presents Cold Cuts, no baloney.
Just science. Hi, I'm Joanna.
And I'm Steve.
And this is a container of liquid nitrogen.
And this is a really big balloon.
Let's see what happens when we place the balloon in the liquid nitrogen.
Okay. Oh, wait. Isn't the balloon gonna pop?
We'll see.
Oh, man.
Now, you notice the balloon shrinking. So you got to think about why is it shrinking?
Huh. Okay, so the balloon didn't pop. There's obviously a hole in the balloon somewhere because the air is leaking. So maybe instead of popping, maybe the balloon just got really cold and it cramped like an egg, and all the air is slowly leaking out of the crack.
Well, if that's the case, what's the balloon going to do when I take it out?
Nothing. It's a balloon with a hole in it and all the air's gone.
Well, I'd say the air is still in the balloon.
So where's the air?
Right there.
That's water.
No. If that were water, it'd be frozen solid. That's liquid air.
What?
Yeah, so it's pretty
When
cool.
we place the balloon in the liquid nitrogen, the air inside the balloon gets really cold. When particles of a gas get cold, they start to slow down and take up less space. If we can get the gas cold enough, we can change it from a gas to a liquid. That's what happened inside the balloon. We changed all the particles of nitrogen and oxygen to a liquid.
So how do I get my balloon back?
We just have to place it someplace hot, like the table.
Yeah, so this is cool. So they liquefied the air. Mainly, they
So I get
took the oxygen and
Now
turned it into a
reverse.
liquid, and now it blows it back up the
table is
balloon.
making the liquid air inside boil.
And so a fun experiment to do.
Frostbite.
All right, so now we get to some really important questions. Which plastics can be recycled? Anybody want to guess? Good guess. Anything with a number can be recycled. So it could have 1, 2, 3, 4, 5, 6, or 7. And so, for example, one of my favorite polymers is PET, polyethylene terephthalate. That's your Coke bottle. And then there's high density polyethylene, there's low density polyethylene, there's polyvinyl chloride, polypropylene, polystyrene, and others. So we'll take a look at some of these. Okay, now, why should you recycle polymers? Well, if you don't, they end up in a garbage dump. And that's a real problem because polymers don't degrade very rapidly. They can stick around for hundreds or thousands of years. And there's people who study garbage dumps, and one of the things they do is they just drill into the dump, and to figure out how old the dump is, they pull out newspapers, because once you put a layer of garbage and then you put a layer of plastic down and keep the air out, nothing decomposes. So you can actually read the label on the newspaper. All right. Anybody have any idea what this object is? Well, if you're a scientist, it might look like a test tube, but actually it's a Coke bottle. So here it's polyethylene terephthalate. It's number 1, it's PET. And what they do is they take this object and they stick it in, they heat it up, and they force hot air in, and they blow it into a mold, and you end up with a bottle. Of course, if you put a coloring agent, the bottle could be blue, it could be clear, it could be green, depending on what the soda is. But you can make these, and of course, these are highly recyclable. We often charge a dime because we want to encourage people to bring them back. And here's a Coke bottle, and you can see they used to make them in two parts because they couldn't make the bottom strong enough, but now they figured out how to make the bottom a little bit thicker, and so they make them in one piece. And even they'll tell you now that they want you to recycle them with a cap back on, because even the cap is recyclable. So just when you finish these, put the cap on, save them up, and bring them back to the store. All right, anybody know what this is? Yeah, hopefully you look at this and you say, hey, that's a cool container. I can get frosting out of it. Maybe you like chocolate frosting, vanilla frosting. Well, if you think about it, what are these? They're plastics. And there's two different kinds of plastics. The lid has to be really flexible. So that's going to be low density polyethylene. And the base has to be a little stiffer. That's going to be high density polyethylene. So there we go. So the high density stuff is number 2, HDPE, and the low density stuff is number 4. And what is polyethylene? It's just a long chain of carbon. And each carbon's bonded to 2 others, and there's a couple of hydrogens. And these chains are in the order of 1 million units long. And if you pack them really tightly together, you get the high density form, and a little bit less packed, you get the low density form. And they're both exceedingly useful. All right, who knows what this is? Yep, these are balloons, but they're special balloons that you might get on your birthday. You might call them Mylar balloons. So what are Mylar balloons? Well, they're usually filled with helium, or they could be. And in the old days, if you just had a latex balloon that's made from that sap from the gutta percha tree, those would leak eventually. You couldn't put helium in, they would only last a day. But these Mylar balloons will last weeks and sometimes months. And you just don't want to let them go outside because they get tangled up in lines and can cause shorts. But how do they work? Well, they're metallated plastics. And so if you look at this, it's now they just use polyethylene. Originally, they used polyethylene terephthalate, but they run it this way, and then they metallize it. They put a thin coat of aluminum, and that makes it impervious to gases. And so this will keep helium in here. And if you get a good balloon, it might last for months. Now, this orientation is really important because now I'm going to tell you the most important thing you're going to learn today. And that is how to open a ketchup pack or a mustard pack or soy sauce. I'm sure you've all opened these packages and you get it all of yourself or somebody else. And it's very frustrating. And you may wonder, how should I open these? Well, if we understand what they're made out of, we'll know how to open them. So first of all, they're plastic that's metallated. These are Mylar. And that plastic is polyethylene. And if you were making this, would you orient the plastic the long way or the short way? Well, I'm sure you'd probably choose the long way. So basically, if you look here, that's the orientation of the polymer. So if it says tear here and there's a perforation, then believe it, tear there. But sometimes you have no perforation, you should always tear it the long way. And here's one, you can look at this soy sauce package and you see it says tear here. Well, that's correct, it's the long way. But occasionally it will say tear here. Well, no, you should tear it this way, the long way. So there you go. We know how to open these now because we know how they're made. And therefore we know the orientation. Here's another one that's interesting, polyvinyl chloride, PVC. Now, most of you probably know this as pipes for water and hoses, and you can actually use this in your house, but it's also in the laboratory, we call it Tygon tubing. And you may wonder, how can this stiff thing in this tubing thing be the same thing? Well, the way it works is they put plasticizing agents in it. And if we were together, I've got some where we have this tubing and we ran it through some organic chemicals. It took out the plasticizing agent and it gets really stiff. So you can make this in different forms. They used to use this for baby toys, but the plasticizing agent would come out of this and not a good thing for little kids. So now they use longer chain things that don't come out. But here's polyvinyl chloride. It's just these polymer chains with a chlorine group on each side. And so this is number 3. It's got lots and lots of uses. In fact, you may have heard of a vinyl dashboard in the car. Well, what is vinyl? That's a shortcut name for polyvinyl chloride, PVC. So this is the same stuff. And what happens is they used to have this thing called new car smell, and some of your parents probably like this. And what that is, the plasticizing agent in the vinyl would come out after you get a car. And especially when it's new, it smells like new car. Well, you're breathing some organic chemicals. So now they figured out how to make longer chains so they don't come out, but some people still like that smell. And so if you go to a car wash, you can ask them to spray some ethers into your car that smell like new car smell. All right, here's another one. Your parents may have said that sometimes you sound like a broken record, and you probably wonder what that is. Well, here are records, and they're often called vinyl records because they're usually made of polyvinyl chloride and polyvinyl acetate. And if your parents tell you that you sound like a broken record, it's because there's a needle that reads the grooves, and as it goes around, it plays a song. But if one of these grooves is damaged, it will go around the same track over and over again. So if you're saying the same thing over and over again, your parents might say like you sound like a broken record. All right, here's another one, polypropylene. This is number 5. And polypropylene is what you get your sandwiches in, but it's also used to make dishes. And all it is, a propyl group has a carbon coming off the main chain. So these are often known as methyl groups, and this is polypropylene because here's a propyl group, and we make chains that are 1 million units long. Now we get to peanuts, which is polystyrene, which is number 6. And the question is, can you recycle peanuts? Can you eat peanuts? Anybody want to guess the answer to the question, can you eat these peanuts? No, I hear no. Well, if they're made out of polystyrene, you're correct. You can't eat the peanuts. But it turns out that these days you can get peanuts made out of cornstarch, which is a natural polymer. It's a thickener. It's often used for soups and things, and you can eat that. And how can you tell? Well, if these things start dissolving in water, then you can eat them. If they don't, if they're impervious, then you better leave them alone. But polystyrene, you probably know, is styrofoam. And here's styrofoam balls. Here's styrofoam cups. These are all number 6, polystyrene. All right. And here are cornstarch peanuts. So if you've ever seen these, they look like polystyrene peanuts, but they're not. They're made out of cornstarch, and they're fun because if you just put a drop of water, you can lick them if you like, you can make beautiful animals. And they come in different colors. They put food coloring in, and so you can play with these, and so they're very easy to recycle. You can just dissolve them in water, or you can reuse them, but they're cornstarch peanuts, so they're completely edible. I'm not suggesting you do that, but you could. All right, here's another one that's interesting. This is called silicone. And silicone is a polymer. It's unlike the other ones, which are just carbon chains. This is a silicon-oxygen chain, but it's very useful. Depending on how linked together it is, we have silicone that we use for waterproofing, like in showers and bathrooms. And you can make cookware. And here's a bread pan. Here's a cupcake pan. If you're going to make cupcakes, these are great to make it in because you can just pop them out. Or you can even have cupcake holders. If you're a really good cook, you might not like the bread pan because really good cooks like a metal pan, so it puts a nice crust on the bread. This is going to cook the bread a bit more evenly, but that's great for cupcakes. It's great for cookies. All right, here's the big question of the day. How many polymer molecules are there in a bowling ball? Anybody want to guess? You think there's 1 million? 10 million, 100 million? Well, those are all good guesses because we might start off with billions and billions, but it turns out the answer is just 1. Yeah, how can that be? Well, it turns out a bowling ball is completely cross-linked. So every chain is connected to every other chain, and that's how they make it. They start with a polymer and they cross-link it. And so there's just one polymer. It's called polyurethane. You make this, but every chain is linked to every other chain. So technically, there's just one molecule in a bowling ball. You can impress your friends with that question. All right, here is a movie, I think. Is there a movie? Ah, wait, we got the movie starting. Let's see if I can get it to go.
Maybe, Professor, if you go on the slide and click the screen, I think it starts.
Oh, I see. I ended up, I've got to get rid of my laser pointer as the thing. There we go. Oh, this is polyurethane foam. Here we go. See if this works.
This is the polyurethane foam kit from Flint Scientific. Usually when you do this demonstration in your classroom, you can make about 15 demos this size.
I love making these milkshakes.
Today in the Flint studios, we're going to see what we can do with 10 kits.
So they're making polyurethane foam. Pretty cool, huh? All he did is they added food coloring into a polyurethane mixture, part A and part B. See, if anybody tells you chemistry is not a lot of fun, you can tell them differently. And you can buy these kits. There are some plastic stores around, and even you can go to a boat repair shop and they'll sell you these kits because people use this to seal holes in boats. They use it to do insulation in houses. A truck will come to your house and fill your walls with polyurethane foam. This is the same stuff that your car seats are made out of and your couches. So the next time you go in a car and sit down, or your foam mattress, this is what's in there. It's polyurethane, and it's just filled with gas, and it makes really nice things. Oh, wait, they're not done yet. I think they're going backwards now. All right, that's pretty good. All right, here's another experiment that you can do at home. Has anybody seen these? They're called grow bees.
These in the water and they started to grow. We even read a story. Mark, will you show the book there? Because early childhood teachers are amazing at tying literature with pieces of or the experiments. So this is Zach's alligator, really about a book, a little alligator that grows. And Shirley had no idea. Shirley Moselle, who wrote it, had no idea that people were really doing this.
A gator in your pocket.
You got it. All right, you guys ready? All right, let's slide this over. Okay. Ready? Are you guys ready? 3,
How long have these been
2,
growing?
1, about 4 days. Ready?
Okay.
Ta-da!
Oh my God.
So these started out about,
Bigger he is, isn't it? Are you ready? Who wants to hold Clyde? Okay, hang on to Clyde. Okay.
so I've got ones that start out the size of your thumb and they end up
Here you go.
300 times bigger.
So do you see how these? Oh, that's okay. Look at this. So here are these huge growing creatures.
How much
And all we have to
fun
do is
is
put them in
that?
the water.
Huh? You
And
gonna
the
hold these
secret
guys?
is the baby's diaper. So I kind of put all this stuff on the website so people can learn about the diaper secret. But this is the way to go now with growing creatures. And there's plenty of science.
Oh, how
Count,
much
compare,
fun.
classify, observe,
you
measure.
guys.
So the way this stuff works is these are partially cross-linked polymers. And so they suck in water, they expand, but they don't fall apart. They don't dissolve. If you didn't have the cross-links, they couldn't expand. And if you have too many cross-links, you end up with a bowling ball. And so these are often called grow beasts. You can buy them in the store and they'll get to 300 times their original size or more. And then you can dry them out and they'll shrink back up. I've got a brain in my office. It started the size of your thumb, grows up to be a brain. And then if you let it dry out, it shrinks up. Okay, so I think that concludes what I want to tell you, and I'm happy to answer questions that you have. I'll put up this bowling ball so we can have something to look at.
Thank you so much, Professor. That's amazing. I love the videos. That's so cool.
Oh, I see a hand up.
Yes. Would you like to? So we have Nahalia and George. Professor, would you like to answer one of their questions?
Please.
Maybe Nahalia, do you wanna ask a question?
Yes, thank you, Professor. The videos are so amazing and cool. As someone who's concerned about nature and stuff, the one where they were growing it and it looked like a big popsicle sundae.
Yes.
What happens to that as far as like trash? Because I've always been told, and when I've looked into research, that styrofoam or styrofoam type products are actually not recyclable.
So it is, if they have a number on them, they are recyclable, but are they reused is the question that you're really asking. And it turns out these days, that even recyclable polymers, many of them are not used. It depends on the price for that polymer. So number one, the polyethylene terephthalate, your Coke bottle, that will be recycled because it's a very valuable polymer. But most of the other ones, all they can do is melt them down and make park benches out of them or make traffic cones and traffic stops out of them. So right now, if you do recycle, they do tend to put them separately in the landfill. And someday when it's valuable enough, they'll go back and dig them up and reuse them. Now, there is something in my lab, I can recycle polyurethane because it turns out that I'm sorry, not polyurethane, polystyrene, because it dissolves in certain organic solvents. So I can put it in acetone and I can take a huge styrofoam thing and make it into almost nothing. I can take away all the air. But you're right that a lot of them don't get recycled, and that is a major problem. And most of this stuff comes from petroleum these days. When they refine petroleum, they take out gases like ethylene and they make polyethylene out of it, and propylene and make polypropylene. So great question. I think we have some more.
We do. Thank you so much for your question. Thank you, Professor. Before we go into further, actually, thank you, George and Rohan. I see you guys. We do have, we are wondering if you guys are okay with us. We want to capture these amazing moments with Professor. We want to capture this amazing event. Would you guys be okay if we use a screenshot of your beautiful faces in something after, just to recap the events? Is that okay with you guys? I think that applies to George, Rohan, Rokas. If you guys are okay with that, just please give us a thumbs up or ask your parents if that's okay. Yeah, you guys look amazing. Okay, thank you so much. Thank you so much. Okay, so next we have George, right? George, thank you so much for your patience. Please feel free to ask Professor if you have any questions.
So the bowling ball, it's just one extremely long string. So theoretically, you're just holding pretty much one of the largest molecules possible.
That's exactly right. So it starts off with chains that are on the order of 1 million units long, and there are billions of them when they put the bowling ball together. However, after you make the polyurethane, which is what bowling balls are made out of, it's cross-linked. They put this agent in that puts links between all the chains. And so you're right, you end up with essentially just one unit. So yes, it's essentially the biggest molecule that's ever been made. Of course, you could make a bigger bowling ball if you wanted one, but it's the same process that Goodyear did to vulcanize rubber, where you put cross-links between the rubber molecules, and that's how come we have car tires. And until then, we didn't know how to, make tires.
Yeah, that's very interesting. Excellent question. Do you think that answers your question, George? Does that make sense? Thank you. Big thumbs up. I like to watch. Rohan, you also raised your hand. Thank you for your patience. Would you like to ask your question, please?
How do the types of plastics get classified with the numbers?
Another good question. I'm going to see if I can go back a little bit. And maybe not the most exciting slide, but you can see the different numbers here, right? So each of these numbers represents a different polymer. So the most basic of the polymers is polyethylene, which is just a carbon chain going along with 2 hydrogens coming off of each carbon. And that comes in high density form, that's 2, and low density form, that's 4. If you put a chlorine off each carbon-carbon bond, you get polyvinyl chloride. So there's a different polymer. And this one's a polyethylene terephthalate. It's a bit more complicated, a bit more expensive. But most of these are just simply, this is a chloride coming off the chain. Polypropylene is a carbon coming off the chain. Polystyrene is a ring. And so they're simply classified by the monomer, the basic building block that makes the polymer. So you have a monomer. If you put 2 together, it's called a dimer. 3 is a trimer. Longer is a ligamer. And when you get to tens of thousands or millions of units, we call it a polymer. Yeah, good question.
Thank you.
Great. Oh, that's so polite. Thank you. Thank you, Rohan. I've seen you around today. You've been sticking around so much. Just want to say great job today. Okay. Thank you, Professor, as well. We also have a question from Tyler. Guys, feel free if you have questions to leave in the chat or raise your hand. We'll get to you. Tyler asked, Professor, is silicon made of a silicone made of silicon?
Oh, wow. This is a good question. And in fact, some of my colleagues have trouble with this one too. So I want to explain that, and I'm going to see if I can find the silicone. Here it is. Okay, so you are correct in that silicone, the polymer, has silicon, the element in it. Also, people confuse this with silica, which is another name for sand or quartz. So silica is SiO2. Silicon, the element, is just Si, and it's a semiconductor. It looks metallic, but it's a semiconductor. But silicone, the polymer, is a silicon bonded to 2 oxygens and 2 carbons. And this forms a long polymer chain. Again, it can be tens of thousands to hundreds of thousands or even millions of units long. And when it gets that long, we can make it into these different things. We can make it into baking pans. We can make it into caulking. And if you have rain gear, like a raincoat or galoshes, they're made out of silicone and they're waterproof. So it's a really useful polymer. And you can, of course, you can bake with it, which means it goes to high temperatures. But it even works when you go into freezing. If you go into the snow in the mountains, it still remains flexible. And that's because its glass transition temperature is way below 0. So someday you'll learn about glass transition temperatures, but suffices to say with a low glass transition temperature, it remained flexible even in snow.
Oh, wow, we still have a lot more to learn, I guess. Does that answer your question, Tyler? Yes, Tyler says yes. Thank you. Thank you, Tyler. We have one more question, Professor, if that's okay, and then we can wrap this up.
Great.
One last question from Linda. Linda asks, what is BPA in plastics?
Okay, so in order to make a plastic flexible, and I'm going to go to the dashboard if I can find it. Here we go. So we don't want on a cold day that the dashboard shrinks, on a warm day it expands and then it cracks. And if you talk to your grandparents, they all have cracked dashboards from when they were growing up. You don't get that anymore because they put these plasticizing agents. And that's what DBA is. It's a plasticizing agent that goes into these polymers. And one of my favorite ones is dialkyl phthalate ester. And so the phthalate ester is the thing that gives you the new car smell. So a lot of people like that smell, but of course it is a volatile organic compound. And so if you smell a little bit of it, that's fine, but I wouldn't want to hang around a new car for too long. But it is what makes this polymer or plastic flexible. And if you take that out, if you let this sit in the hot sun for a long time and it comes out, that dashboard will crack. And so another way to look at that, if you look at this tubing, that is the same polymer as this hose, but this has lots of plasticizing agent and this doesn't. This just has some fillers in it. So another really excellent question. And as I said, if you take the plasticizing agent out, and we've done that by accident, this hose, this flexible hose, will become completely stiff as this pipe. So man, you guys asked really good questions.
Thank you so much, Professor, for the explanation. Guys, you guys have amazing questions. We also want to respect Professor's time. Professor, what if